Now, at first glance, this problem looks impossible, but I assure you it is quite doable. The problem is, it's not currently in a form that's very useful to us. So let's rewrite this and see if we can identify something good here. So let's leave n equals 0 up to infinity, but let's rewrite that denominator as you know, itself in factored form, because it's a quadratic. But instead of n squared plus 3n plus 2, let's write that as n plus 2 times n plus 1. Hopefully at this point you're seeing the idea that we should probably separate this out into two separate fractions. So we are doing a partial fraction expansion here, which means what we're going to do is we're going to say, let's let this fraction 1 over n plus 2 times n plus 1. We want to break this back down. We want to decompose it into, maybe something that it was before we found a common denominator and combined it. So let's write it as just some numerator a over the first factor, n plus 2. And let's add to that some separate numerator b over the second factor, n plus 1. And I'm making the claim that these two things are equivalent. Now I just need to figure out, well, what could A be and what could B be? And so to do so, it seems kind of silly, but now I'm going to actually find a common denominator. And to do so, if I want a common denominator of, well, n plus 2 times n plus 1, look at that first fraction, a over n plus 2. I need to multiply by n plus 1 in the top and the bottom. So I get a times n plus 1. And then in the second fraction with the b, I need to multiply that by n plus 2 over n plus 2 to get that common denominator. So I have b times n plus 2, like that. And now notice in the right here and in the left here, we have a common denominator, n plus 2 times n plus 1, which means that numerator 1 has to be equivalent to that a times n plus 1 plus that b times n plus 2. So we have 1 equals a times n plus 1 plus b times n plus 2. And we just need to figure out, well, what values of a and b make this true. Because this needs to be true for every value of n. And so if we're clever, we can choose a couple key n values that will allow us to find a and b. Well, if this is true for all n values, then it's certainly true for n equals negative 1. Because if we let n equal negative 1, then think about what happens. Well, that term goes away, because negative 1 plus 1 is 0. So all we're left with is that b fraction. So if we rewrite this with n equals negative 1 plugged in, a times negative 1 plus 1 goes away, that's gone. So all I have is my plus b times negative 1 plus 2. I'm plugging in negative 1 for n. And so I have 1 equals negative 1 plus 2 is positive 1. So I have 1 equals b times positive 1. So 1 equals b, which is nice. Now let's be clever again, and let's let n equal negative 2. Because now I will have 1 equals a times negative 2 plus 1 plus b times negative 2 plus 2, which will go away because that's just equal to 0. And so I have 1 equals negative 2 plus 1 is negative 1, so I have negative a, which means that a equals negative 1. So I've found the values of a and b that make this true. So now I can go to this middle piece right here. I have found my partial fraction decomposition, my partial fraction expansion, and I can rewrite these with a and b plugged in. So remember, we were looking at the summation from n equals 0 to infinity, but now, instead of writing this whole ugly quadratic mess, I have simplified this down to the sum of two fractions. So I'm going to write my b fraction first, since that has a positive coefficient. b is 1 over my n plus 1. And then since a is negative, I'm going to write that as minus. My a value is 1, but it's minus. That's why there's a minus between them. Over n plus 2. And you might still look at this and be like, well, how did that help me? I still don't know what this sum is. Well, start listing terms and look at what happens. Well, when n is 0, I get 1 over 0 plus 1, so I just get 1. Minus that second term, 1 over 0 plus 2 is 1/2. So that is when n equals 0. And then what about when n equals 1? Add that in. Well, now I have 1 over 1 plus 1 is 2. Minus 1 over 1 plus 2 is 3. And look what happens. Those terms cancel out. That was n equals 1. Let's do one more just to be certain. When n equals 2, well, then I'm going to have 1 over 2 plus 1 is 1/3. So hey, look, that cancels already. And then minus my 1 over 2 plus 2 is 4. And that does n equals 2. And I could do the same thing with n equals 3, and I would get another plus 1/4, and then I would get a minus 1/5, and a plus 1/5, etc., 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 forever. And so the only term that does not cancel out is the first one, 1, and so this sum is equal to 1.